In this video, we'll be designing a combinational logic using PLA, and this is a second example. The link for first example is given in the description box. And now here we have to design a combinational circuit. The combinational circuit is described using the function f1 and f2, and we have to implement the same using a PLA. Specifically, they have given us we have to use 3 cross 4 cross 2. Let us understand what is this 3, 4 and 2 first of all. So how many output functions we have? We have functions f1, f2. Therefore, we have 2 functions. Therefore, this 2 stands for output. How many input variables we have? A, B and C. So, A, B and C. Therefore, we have 3 variables. So, this stands for input. In case if the function they have specifically mentioned as A, B, C, then from that we can identify the number of input variables. If it is not given, then we have to observe the minterms. By looking at the minterms, we have to start with 0 because we have 0. Then we have 1, 2, 3, 4, 5. Maximum we have up to 5. So the window is only from 0 to 5. Therefore, we have 6 minterms. So totally 6. Therefore, how many number of input variables we need? If we have 2, then 2 power 2 will be equal to 4. Therefore, it is possible to have only 4 minterms. If we have 3, then 2 power 3 is equal to 8. So 6 minterms can be covered only by total number of 8 minterms. Therefore, we need 3 inputs. Therefore, this could be 3. Right now, we have something called 4. So 4 is nothing but the total AND gates, that is programmable AND gates available in the PLA. So now with this introduction, let us start working on with the problem. So we are given with 2 expressions f1, f2. So we have 3 input variables A, B, C. If we have 3 input variables, then it should start from 0, 0, 0 till 1, 1, 1. We have all different possibilities of minterms. So now when we look into f1, what are all the minterms that are present? We have 0, we have 1, we don't have 2, we have 3, we have 4, we don't have 5, 6 and 7. Similarly, f2, what are all the minterms we have? We don't have 0, we have 1, 2, 3, 4, 5, we don't have 6 and 7. So therefore, the truth table is done. So here is a digitized form of the truth table. So we have 0, 1, we don't have 2, 3, 4 and rest we do not have. So 1, 2, 3, 4, 5 we have and rest of the terms we don't have. So therefore the truth table is done. Now we have to go for the second step, which is nothing but we have to use a K-map and find out the expression for the function f1 and as well as f2. Let us do for f1 first. So how to plot? We have 3 variables A, B, C. Therefore this should be a 3 variable K-map. So we have 1, 1, 0, 1. So 1, 1, 0, 1 and 1, 0, 0, 0. 1, 0, 0, 0. So if we try to group, it is possible to go for grouping 1 and grouping 2. When we write expression for this group 1, A is not common because it is 0 and 1. When we compare BC, both BC are common to these 2 minterms. But both are in its inverted form. Therefore, we can write it as B bar, C bar. So B bar, C bar. And when we consider this grouping, A is common, which is in its inverted form. So A bar. And when we look into these 2 variables 0, 1 and 1, 1, which is nothing but BC, C is common. Therefore, we can write A bar and C. A bar and C. Therefore, the output expression could be F1 is equal to A bar C plus B bar C bar. So, this is the expression for F1. In the same way, we have to do for F2. Similarly, if in a 3 variable K-map, we have to plot 0, 1, 1, 1. So, 0, 1, 1, 1 and 1, 1, 0, 0. 1, 1, 0, 0. So, when we try to plot, this is a first group, a second group, a third group. Maximum 3 groupings are possible. When we look into this group, we have A in common. When we look into column wise, it is 0, 0 and 0, 1 for BC. So B is common. Since it is in inverted form, we write B bar. Therefore, A B bar becomes the expression. So A B bar. When we look into this group, we have A bar in common. When we look into column wise, it is 0, 1 and 1, 1, which is nothing but BC. C is common, therefore A bar C. When we look into the third group, A is common, so it is in 0, therefore A bar. When we look into column wise, it is 1, 1 and 1, 0, which is nothing but BC. So both are 1, therefore we have to write B, A bar B. So we have written A bar B. So what will be F2? A bar C plus A bar B plus AB bar. That becomes a function F2. Therefore we have identified F1 and F2. Next, we have to go for PLA program table. Right now, we have the function F1. It has A bar C and B bar C bar. This is one product term and this is the other product term. So, A bar C and B bar C bar is the product term. And next, if we look into the next expression, in F2, we have A bar C. Already we have A bar C in F1. Therefore, we are neglecting this A bar C in F2 plus we have A bar B. Do we have it here? No. Therefore, I am writing A bar B. Plus we have A B bar. Do we have A B bar in F1? No. It is a unique term. Therefore, A B bar. So, what we have to do? We have to compare all the expressions. Right now, we have only two expressions. Therefore, we have to find the unique product terms and list out all those unique product terms from the expression here. This is the first step. Then what we have to do? We have to plot the inputs. So, we have three inputs A, B, C. What are all the variables that we have here? It is A bar, inverted form of A, therefore 0. We have C, therefore we are making it 1. We don't have B, then let us mark it with a hyphen. We have B bar, therefore 0. C bar, 0. We don't have A. We have A bar, therefore 0. We have B, 1. We don't have C. We have A, B bar, we don't have C. Therefore, the input table is completely filled. Now we have to go for the output table. What are the outputs? We have F1 and F2. What does F1 carry? F1 carries A bar C plus B bar C bar. That is A bar C plus B bar and C bar we have. And similarly, what does F2 carry? It carries A bar C. Therefore, A bar C plus A bar B. So, A bar B plus A B bar. So, A B bar we are marking with 1. So, this is the programming table for the output. So, in both the conditions we are just implementing in its direct form. So, therefore, it is true. So, we are making with T and T. Now, let us jump on to the implementation. So, first when we look into F1, what are the terms it has? It has A bar C and B bar C bar. So, A bar C, B bar C bar. So, we have one product term, second product term. What is the third product term? It is A bar B. A bar B. So, A bar B. What is the last term? A B bar. So, A B bar. We have four product terms. Now, what does the term F1 have? Function F1 have? It has A bar C and B bar C bar. So, A bar C and B bar C bar for function F1. What does function F2 have? It has A bar C because we have a 1 here. A bar C. We have other one here. A bar B bar. A bar B. We have another one here. A B bar. A B bar. Therefore, function F2. So, hence we have implemented the logic into a PLA. So, now in the initial question it was written as 3 cross 4 cross 2. So, we have two outputs F1 and F2. We have three inputs A. So, A, B and C. We have three inputs and we have four AND terms, that is product terms using AND gate. So, here is a 3 cross 4 cross 2 PLA. And writing this A complement, B complement and all those are been explained in the first example itself. You can refer the video for that. Thanks for watching the video.